Welcome to the webinar Creo Parametric Simulation Elite, already used. My name is Urs Simler. I'm looking forward to give you any information about Creo Simulation Elite. First I will talk about me a little bit, then about my company, about the company I'm working for, Avenic, and then about the module in Creo Parametric. This is part of Creo Design Essentials subscription license. It's called Simulation Elite. And we'll have an overview about the functions. We'll see how we have to install and configure the product. And of course, the most of time will be in a live demonstration. At the end of the day, we'll also have time to, or you will have time to ask some questions. Please use the question panel for that because you're muted. Okay, about me, my name is Simler. I'm CAD simulation specialist. I'm working for the company Avenic, and about in the last 30 years, I've worked 20 years for PTC as a simulation specialist. Here are the coordinates of my sales manager, Daniel Losley. Do not hesitate contacting us if you have any questions. Then some points about Avenic. Avenic offers different CAD and PLM positions. We are a reseller of PTC, therefore we care about PTC Creo Parametric, Elements Direct, Windchill, and the PTC products. And as a reseller, we also have our own tools. We call it Searchwide. We have some Windchill apps, and we have Mima Morrison for monitoring Windchill. And as a reseller of PTC, we also cooperate with other software partners from PTC. One of them is CAESS for topology optimization. The other one is eLaborate for electrical clearance and creepage analysis. We also resell products from TechSoft. TechSoft now is part of a company called Mate. And we also cooperate with SF Software Factory from Munich in Germany. By the way, we are monitoring a PDM system from different customers, and we have an own training center in Oftringen, and of course we also do online workshops, and we are quite experienced. Okay, the topic of today's webinar is Simulation Elite. Simulation Elite is part of Creo Parametric Design Essentials, and in the last years the most of customers moved from perpetual licenses to subscription licenses, and in the subscription license you got let's say this tool here, Simulation Elite. You'll find maybe in the license file here these strange topics here. And the most of you, they never used Creo Simulation Elite, and I want to show you what's behind that tool and how easy you can use these advantages of this structural analysis tool within PTC. With that tool you have the capability to do linear static analysis on parts and assemblies. There is no limitation of the model size. You can use linear material behavior. That means when you have here the stress strain curve, then when you look at the steel behavior, it looks like that here. But in Creo Parametric Simulation Elite, you only can use here the orange linear behavior. So linear material properties. In addition to that, you can use shell, beams, springs models. You can add some masses When you're working in the assembly environment, the interfaces are bonded or free. There is no contact capability available in this tool. You can use volume and surface regions to split surfaces, volumes, to bring in special loads or constraints. You can do that also with multi-body capabilities starting at Creo 6 in Creo Parametric. You can add some mesh refinements. I will show you that later in the live demonstrations. And you can use welded links and rigid links. I will show you the welded links during the demonstration. Before you can use the tool, you have to make sure that Creo Simulation Elite is installed. Therefore, you have to checkbox, or your CAD administrator during installation, the Creo Simulate checkbox. Then the product will be installed in the older versions of Creo until Creo 8. The installation is here under that path, starting from Creo 9. You have this path here. And there in the text license Mac folder, you'll find here the license or feature.dot information, and you have to make sure that you have these two lines in this file. But normally the installation is doing that for you. And it would make sense also to replace a so-called template, SimPaper static template, .rwt, to have nice result windows in the post-processor of Creo Simulate. Normally you can replace this file without admin right. If you need that file, you can send me an email. And of course, it would make sense to have some special config pro options and maybe also some map keys to speed up the process in Creo Simulation Elite. If you need that file, send me also an email. And now we are going for the live sessions. During the next 50 minutes, we'll have 5 projects. One is a bicycle crank arm. We are calculating a plastic clip. We are doing a casted component with a step import from GrabCAD. Then we will see the shell model with an oil tank. And at the end, we are going to the assembly, and we are analyzing a weld assembly. So now let's go for Creo Parametric here. I started already Creo Parametric. I think it's a version 9. And you can also use Creo Simulation Elite in version Creo 4 or so. And the target of our analysis will be, here we have a load of 1 kilonewton. We constrain our component in with these holes, and then we'll still see the stress behavior. This is an original component from Truvative, but this logo, I don't want to use that during simulation. Therefore, you quite often do some simplification, and I'm going to suppress, let's say, this feature. Okay, and now I'm entering the Creo simulation mode. The first thing you should do, check your units, because normally for construction you use kilograms, and for simulation you want to change to newtons here. So select newtons, millimeter newton seconds, go for set, and everything is done. Now you're safe. You can type in the loads in newtons by default, and you get in the post-processor megapascals by default. That's very easy for you when you change that at the beginning. Now we are selecting some holes here, and we are going to set up a constraint here, displacement constraints. By holding down the control key, I can select those 4 holes. Okay, and I'm going right now for that area where my load comes in. I'm going to load my component with an advanced option, which is also included in the Simulation Elite, called total load applied at a point. I'm selecting that point, and I'm typing in Z direction here I want to bring in 1000 newtons. I'm holding down the preview button and you see here, okay, when the load is acting here, you're getting here a moment, and of course you're getting here force. So that means we have a very realistic load implemented. And that's more or less all. The only thing you have to do, you have to check if the guy who modeled that component, did he already assign the material? No, he didn't, and therefore we're going for our library. And from our library, we are just selecting an aluminium, and we'll see here the values we need, at least Poisson ratio and Young's modulus. So this material is in the model, but we have to assign this material to our component. Now we are done and we can say, okay, let's set up here an analysis. Here we see the analysis which is available with Creo Simulation Elite. If you go for other thing, it will tell you, okay, this is not available. You need another license. So you can, with Simulation Elite, just do static analysis. And I'm doing my first analysis here. And I say, okay, I want to run that one. Now in the background, Creo Simulate is meshing the component. I can see that here in the log file. It's creating solid elements, tetraeders. These are done right now, 8000. And now it's calculating that one. It's solving the equation. At the first step, it's doing with P order 3, and then it's increasing that P order in the areas where you have the stress peaks. And it's giving you the results. And I can go for the post-processing. With this template, I was substituting after installation. We'll see here the behavior. We see the scaling is about 64. So it's much more than in reality. And right now we are going here for the stress von Mises, and we can see here the stress results. If I'm double clicking on the background, I can show here the element edges, and I can see Creo Simulate was taking a very, very coarse mesh here. And of course we see here the stress behavior, and it's quite realistic that this radius here that we can see here, the highest stresses, it's around 200 megapascal. But we see the stress distribution is not very nice. Therefore, we are doing the next step, and if we want to see what happens if you're refining our mesh. Of course, we should know how big this component is. Therefore, I'm going for inspect this line here. It's 12 millimeters, and with this information I'm going back for mesh refinement. I say, okay, I want to have a maximum mesh on the whole component of what is it? Let's do here 9 millimeters. Okay, 9, and I'm going here for this radius where I found the big stresses here. I'm zooming in for the first radius. I'm zooming for the second radius here, and I say, okay, these areas, they should be meshed with a size of 1 millimeter. Okay, therefore I'm getting a much denser mesh, and I'm calculating that again. On the analysis tab, I'm setting up the next static analysis. It's called BBB. Okay, I'm running the analysis. Again, I'm going for my information file here, log file, report file. I can see, okay, I'm getting a little bit more elements. It's maybe around 12,000. And again, it's solving my equations. And after another 20 seconds, I can see the new results, and I can compare it. So I'm going for post-processing. I want to see right now just stress von Mises with the elements. It's looking like that. That was analysis A, and I'm opening the results from analysis B. It seems to finish right now. Okay, and I want to see here the same stress and the element edges. When I'm holding down and selecting the windows with the shift button, I can spin around both of them. And of course here, when I'm zooming into that area, I can see here, okay, with the denser mesh, I'm getting much more meaningful results, but the results are not that different. I can go in and show me the maximum view here. It's to 198 megapascal with the coarse mesh, and here we have 207. This is more or less, let's say, the same value, and of course the right one has to be the better one. Okay, and on this let's say on this result window, I can go in and with the help of map key, I'm just hiding, let's say, the areas with low stresses, and I can see it might be a possibility to take out here some material, because a mountain bike has to be in weight, has to be optimized, and it might happen that here I can take out some material. So I have an idea how to do that, and I'm going back for my Creo Parametric environment. So I'm closing Creo Simulate. I'm going for modeling. I want to model on the plane B. Here some cutouts. Okay, I'm going here for sketch mode with the help here of a circle. Just say, okay, I'm taking here out some material. Maybe here, want to take out something. And here on top, maybe something like that. Okay, I do not want to add material, I want to remove material, so right now. And I'm rounding here those edges with a round of 2 millimeters. Holding down Control key, selecting the other edges. And I have a new variant. Whoops. It seems to here a little bit dangerous, but let's check it what happens to the stress behavior. Going back for Simulate, Analysis tab, setting up the next static analysis called CCC. And with the green flag, I'm starting the analysis. So I know within about 25 seconds I will see the next results. I can check that here in the status file. Okay, meshing is done. Again, around 12,000 elements, and that takes me 20 seconds, something like that. And now I really can compare the, let's say, first version with the second versions. Is it possible? What are the stresses doing? I'm going for the first version here. In post-processor, I want to see the stress behavior with the element edges. Looks like that. And in addition to that, from the version CCC, I want to see the same things. Okay. Now it seems that the stresses are very different here. And also with the help of a map key, which is in the config profile, I'm selecting, let's say, the same legend levels. Okay, now the colors are the same for the stresses. I can hold down the shift button and maybe zoom in here. And I can see here, okay, in that area, stresses is becoming, let's say, in the same range here as on the radius here. So that means with let's say less material, I do not get much higher stresses. So that means I can optimize here this crank maybe in a way that the weight is coming down by 20-25%. You just have to check some variants and play around, and then you can save quite a lot of weight and material. So that was my first project, this crank of a mountain bike bicycle. I'm going for my second project. Second project is a plastic clip. And on that plastic clip here, I have to search for a PDF. I want to deal with that behavior on campus plastic. I found that material, and I want to work with that material here. Okay, and how can I find out, let's say, the Young's modulus? It's quite easy. You just go in and you're drawing a line, and this line should follow, let's say, this pink line here in that area. Okay, and we see here we have 2% of strain, and we see, okay, my line here is crossing the 2% strain line, that area. I'm going to the left side, and I guess here this is maybe 137 megapascals. I just have to multiply this value with a factor of 50, and then I'm getting the Young's modulus. So when I'm opening here my component, this plastic clip, I'm going with them to Creo Simulate. I can see here in the material information tab, okay, we have here 6,850 megapascal. And when you have plastic components, let's say this value of 0.345, quite easy to remember, is always a very, very meaningful Poisson ratio value. Okay, this material, I think it's just there, and I have to assign the material to my component. And then I'm going in and say, okay, I'm selecting here those four surfaces, and I'm constraining them. In that area, I'm selecting an edge here, and I want to press down this edge by a value in the minus y direction, so it's this direction. I want to bring them down by minus 2.5 millimeters here. Okay, and later on I want to also know what is the force I'm needing for pressing down that 2.5 millimeters. Therefore I'm creating a so-called measure. I name it F1, and this measure should measure for me a force on a constraint, a force on that, okay, constraint here. And later on in my status file, I will see in the results the force. Okay, everything is done. I'm going for my Home tab. I'm setting up the next static analysis. I'm making DDD. Oh, let's do it like that. Okay, and I'm running the analysis here. Okay, this is a very small model, has only 2000 elements, so it takes just some seconds to analyze. Going back again for post-processing with my template, it's showing me the behavior here, displacement behavior, and of course it's showing me the stresses here. And when I'm double clicking that one, I can show my edges, and I can see, okay, this is quite coarse. And here I can see this seems to be the peak of the stress. Here it's not calculated very, very nice, but we'll check later on how good is this value here. And of course here very, very coarse elements. Therefore, I know the stress is around 52 megapascals, and I'm just going back to analyze that one with a denser mesh. Before I do that, I'm checking my status, and here I can see the load I need to press down this clip by 2.5 millimeters. It's 25 newtons. Okay, but now I'm doing here the nice analysis. Again, I'm inspecting here this length, it's 4 millimeters, and therefore I'm going in to make a mesh refinement on the whole component. And this should be, let's say, around 3 millimeters. Okay, by looking from top here, it's quite easy to select for the mesh refinement. First I have to press mesh refinement button, then I can select those surfaces. It's quite easy to select all the surfaces here, and I want to mesh them with maximum 0.6 millimeters tetraeders. Okay, this is also done, and I'm just doing the analysis again to have a very, very good stress results. I'm going again for new static. I call it EEE. Okay, and I'm running the analysis again and checking the status. 9,000 element takes maybe 10 seconds for analyzing, and now we should see, let's say, the perfect results here. It's nearly done. Going for post-processor. Here we see right now it's done yet. Now, and with, let's say, this one here with the template I was substituting after installation, I can see the behavior. I'm just going for my von Mises stress. I'm double clicking that one, showing the edges, and I just want to see maybe the old calculations with the coarse mesh. Therefore, I'm opening the DDD analysis, and I want to see here again the same result window. Holding down that one, zooming in to that area. Of course, everybody sees this is a better result than that one, but this result here is quite good because it's telling us it's 52 megapascal, and here we have 49.8. For simulation, that's more or less the same result. And of course, the results on the left side looks much, much better. If I'm bringing in here so-called cutting plane, then I can see here the perfect behavior of my stresses. Okay, so we already did the second project, the plastic clip. Therefore, we want to go for the third one. This is a casted component. I loaded it down from GrabCAD. I did not modeled that one, and I want to show you how we can analyze this one here. And I'm opening here a step file. Okay, and it's coming in, of course, with, let's say, the Creo Parametric template. Therefore, there is some material here, still low carbon, but I think it's not, no, yes, it's assigned here because I have the blue arrow there. I'm going again to my application Simulate, and because it's coming in with, let's say, the standard templates, I have to switch the units from millimeter kilogram second to millimeter Newton second. And everything is okay. I'm going here again for displacement behavior on that surfaces here. I want to constrain my component. Okay. And I will bring in some loads here. We have a pressure inside here. I'm selecting a surface inside my component, holding down the shift button, still holding down the shift button to select all my surfaces. I have to spin around my component, holding again my shift button and selecting that one. Therefore, I'm selecting all the surfaces in my component. And then I'm just pressing here, I want to add some pressure. And I'm typing in here with a bar. I want to have a load of 250 bars. Okay, can see the preview button and do here an OK. I'm going back for Creo Parametric because I forgot to mod something. I just want to do a sketch here on that side. And this sketch is starting here in the center. It's going over there. And I'm just filling that component because I just want to know or analyze what's the area. And it's 5,568 square millimeter. I copy this value. I'm leaving that one. I'm hiding that surface. I'm going back for Simulate. And because let's say here my component is opened, I have to add here a force which my pressor is acting. Therefore, I'm going in and say, okay, on that guy here, I'm bringing in a force. It's 250 bars, 25 megapascal. So I'm adding a force in that direction plus y direction of 25 multiplied with Control V, 5,568. Okay, in that direction I'm going for this one, doing here the same force, Control V. Okay, and this is okay. And here maybe on that cylindrical surface I'm adding a bearing load. In minus Z direction I want to bring in 5,000 newtons. Means from that side here I have force. It's just a pressure force from one side, so-called bearing load. I'm doing here the same from the other direction. Bearing, and this is plus 5,000. Okay, hit the preview button. Oh, you have to type in the Z direction, not in Y direction. Okay, thank you. And hit the preview button. So I would say everything is done. And I'm checking here the material. I don't want to work with steel low carbon. Therefore, I'm going again here from my material library, and I want to take here this FE40, and therefore I have to assign this FE40 to my component. Now everything is done. Going back for my setting up my static analysis. I call it G. Okay, I'm running the analysis. And I'm watch the RPT file, report file, and I can see, okay, this is running very quick because we only have 4,000 elements. So with your license, depending on the memory you have on your computer, you can solve up to 500,000 equations. Okay, everything done. I'm going here again for that one, and I can see here the results. Okay, now my boss is coming and telling me, oh, what are you analyzing here? I say, okay, loaded that down from GrabCAD, and it tells me, oh, this hole here is not necessary, and he want to see maybe a variant where he's moving that part here a little bit up. I'm telling him, oh, no problem, although it's not modeled in the Creo Parametric, I can let's say, create a new variant with the help of flexible modeling. Flexible modeling is also part of Creo Design Essentials. Okay, in flexible modeling, you can go in and say, okay, I want to select here the hole, and I want to remove it. Middle mouse button, it's done. I want to maybe watch from front here, and I'm going here for selection mode. With a rectangle, I'm selecting all the surfaces here. Now I say I want to move that guy a little bit. Okay, you can also move that with a specific value. I'm just dragging it right now. Well, dear boss, is it okay like that? Yes, it's okay. And it's moved up, that little thing. And maybe for later reasons, when I want to, let's say, remesh maybe this radius here around that, I can also use a feature from FMX by editing around. I select here around, it's detecting, oh, there is around me a lot of surface patches. I'm holding down the control key. I also want to select that one. That means now I could change this radius, and I can select it with a feature, this surface later on for maybe mesh refinement. Now I'm going back again for Creo Simulate. I have my new variant, and right now I want to bring in again here some mesh refinement on the component. And I say, okay, on the component, I want to have maybe, it's quite a big model, 23 millimeters. And I'm going here, watching from front, Going for that area, and I want to bring here on that component here a maximum mesh size of 9, and I want to bring here another mesh refinement. Now I'm going for intent feature, therefore I can select here the radius patches, and the radius patches, they have a mesh size of 5. So I think after half an hour of watching this webinar, you're now a specialist in meshing components within Creo Simulate. And the only thing you have to do, you have to set up a new analysis, new static analysis, I call it HHH. Okay, and again, running the analysis. Of course, now we should get a little bit more elements because we want to have a nicer stress behavior, 17,000. Unfortunately, no time for grabbing a coffee because we are nearly done. It's taking maybe another 10 seconds until we can see the perfect stress behavior of the component. Now it's going here for post-processing solution. That means for me it's nearly done, and hitting that button for having a look at my stress result. I do not deform it. Okay, we'll see it like that. I'm changing here my format of the legend or the legend levels. I have a map key for that one. Okay, and there is also capability to add some, let's say, capping surfaces in order to have to view inside that component. And here I can see, okay, that are my stress results. I can cancel this again and maybe buy the other map key. You can see here where are my big stresses. I'm just dragging here up and down, and I can see where do I need more material or where can I work, let's say, with less material. This is quite helpful, this capability of hiding the low stress regions. Okay, that's all from, let's say, this casted component. And in addition to Creo Simulation Elite, we saw flexible modeling extension. Okay, the third project is done. Now we are going for the fourth one. Okay, we are selecting the next working directory. It's the shell model here. And I'm going to open here an oil tank. This oil tank here has very small shell thickness, around 3 millimeters, and the height of this oil tank is about 2.5 meters. Therefore, it's nearly impossible to mesh that with volume elements because you're getting too much. But we'll use in Simulate the capabilities to deal with shell models. The shell models are also included in Creo Simulation Elite, and I can go here and search for or detect the shell pairs. I just have to type in a characteristic thickness. I say, okay, it's under 6 millimeters. Start and create those shell pairs. You can see right now nothing here. I'm pressing start and he created 137 shells for me. Now it will not work with volume elements, it will use shell elements. Of course, we need a constraint here. Now it's selecting the shells, a little bit stupid from my side, therefore I'm going for just selecting surfaces right now. Now it's selecting the surfaces. I want to see that from front. I'm going for the Home tab and I'm making a displacement constraint on that surfaces down there. Okay, and now I will bring hydraulic pressure on inside my component. I created here a coordinate system, CS0, that one. And depending on that CS0s, I want to bring in, let's say, the oil level here. Okay, and therefore I have to use a special load distribution for my pressure. First, I'm selecting here, let's say, just the surface on the inside of my tank. I'm holding down again the shift button. I'm selecting the border here. And it didn't work because I was, oh wait, I have to go, I think, again for surface. Okay, let's take that surface, hold down the shift button. Now everything is selected inside. Let's say, okay, I want to bring in pressure. Okay, and this pressure will be done with an advanced function of coordinate. I already created that function. It looks like that here. And this one is, let's say, the weight of the oil. Okay, and with an if function here, we see that when I'm reviewing this function, plus between minus 500, oops, and plus 2002 meters. I want to see my graph. That means, okay, above the level here, I have no pressure, and the pressure is increasing when it's going down to 2.5 meters. Okay. And I say, okay, and here I'm just multiplying that function with a factor of 1. I'm hitting the preview button, and you see now, quite nice, the behavior, the pressure behavior, hydraulic pressure. Okay, that's all. And now I'm just going in and I say, okay, I want to refine my model. I'm bringing in the mesh control on the whole component of 150 millimeters because it's quite big. And I'm going for my home tab and I'm assigning here, the PTC system material, steel, to my component, and I'm setting up a new static analysis. I call it EEEE. Okay, and I'm running the analysis. I think this analysis takes a little bit longer because of the shell elements, and therefore I'm just going for post-processing of the already analyzed component. Going here for my post-processor, and I want to open here some results. I calculated that one with 3 millimeters. Okay, and I can show here the behavior of that one. And we see, okay, with 3 millimeters we have 900 megapascals. I'm want to see maybe the results of the 5 millimeters variant here. Okay, and I want to see that one in the second window. I can select both. And maybe here I want to have the same legend levels. Doing that with the map key on the left and on the right side, and we see, okay, the 3 millimeter variant on the left side has much bigger stresses than the one on the right side with 8 millimeter shell thickness. Okay, that was our fourth project. Okay, and I think in the meanwhile, now it's still on the way, but it's nearly done. It's about to finish. The analysis is done. I'm going for the last project. Last project is here in chapter 5. Okay, and I'm opening here an assembly. So with Creo Simulation Elite, you can analyze big models. This is just depending on the memory on your computer, and you do not need a special graphic card to analyze your components with Creo Simulation Elite. Now we're going for, we see here, we used also a module weld. It's also in Creo Design Essentials. We did the welding here, and we applied the welding as volume features, and we used that volume later in, or now, in Creo Simulate for our analysis. Again, we are going here for a constraint. That surface is here. Okay. We want to just apply here on that height a load. Therefore, we are doing here a volume region on that component. Right mouse button within internal sketch. Here we want to substitute, or we want to subdivide or divide the geometry here. Okay, 100 millimeters. Okay, so we're getting here a new surface. On that surface, we are bringing in again a bearing load of 75 kilonewtons, and we are dealing here with the direction in maybe that direction we want to bring it. So +1, next direction, +1 in that direction, total 75 kilonewtons. Preview, okay. And here on that area, we want to bring in also a load. And by selecting like that here, all, let's say, the green surfaces are selected, and with the option total load at the point, I select here that point. I want to bring in Y direction a force of 5,000 newtons. Okay, hit the preview button and we see again here a moment applied to that geometry. Okay, that's nearly all. Here we see some connections are already done. The most welds are connected right now. Only the blues are not connected. Therefore, I'm going in and I say, okay, refine model. I want to use the weld connections from the weld feature. I'm just selecting that weld feature. It knows the material properties, the thickness, and everything is done. Now I'm doing the final analysis. Therefore, I'm controlling my mesh over the whole component. I want to have a mesh size of 50 millimeters. Oh, it's nothing selected. I have to select here the whole assembly. Now it's okay. And I'm going to hide all the components here because I want to now mesh the welds a little bit denser. I'm going here for control the mesh, the surfaces. I'm dragging a rectangle. Oh, again, dragging a rectangle. Now, and I say the size here is much dense, it's 15 millimeters. Okay, I'm showing those again, and I can start here under the Home tab, my last analysis, doing new static, Q. Okay, and I'm running that one. Yes, let's check here the status, generating the elements again, and we're waiting for that. If you have any questions, please feel free, use the question panel, because in 2 minutes I'm going to answer your questions as soon as we, let's say, can see the results of the last analysis. Okay, 20,000 elements. The first step is done. Okay, now it's checking convergence, and in the areas where we have the big stresses, it will increase the mathematics. Calculate it again, and in about 10 seconds we'll see here the results. So I can go here for my post-processing with my standard default template, and I can see the results again. Displacement behavior. Of course, the scaling here is a factor of 128. Okay, but then you can see what happens, what's the behavior. Do my constraints are working okay, or the forces okay? You can check that quite easily with this topic. Okay, again, going here for stress behavior. I'm changing here my the stress levels, and I can see here, okay, where are the high stress levels? Which components do I need? Is it necessary to have here maybe a rip? Oh, let's make it red like that, or that kind of stuff. And of course, so-called capping surface feature here, you can see where are the high stresses. Okay. And with that feature here, you can, let's say, optimize your components. Great. So that's more or less all from my side. So I'm going back for my PowerPoint. We saw right now the bicycle crank arm, the plastic clip analysis, a step import of the casted model. We modified that one with flexible modeling extension, and we used the shell model, which is also included in Creo Simulation Elite. And at the end, we went to an assembly, and we analyzed that assembly, which was also created with weld features. That brings me to the last points here. I mean, you might have, or the most of you, I would say nearly all of you, will have this license for Creo Simulation Elite. There is also advanced license of Creo Simulate, but with the Creo Simulation Elite you can do static analysis, and it would make sense to use this tool because the most of analysis a company is doing is static analysis, and the only thing you need a little bit education, and with the help of online or on-site workshop of one day, I think you can prepare your people to use Creo Simulation Elite in a good way. And I think it makes sense to know a little bit about meshing, about constraining, about doing the post-processing. And I think within one day, with a workshop of one day, your people will be able to do that. We offer that as an on-site training, as an online training. The on-site training can be in your company because we have also 9 laptops. We can bring them to you and everything is installed there. So if you need that kind of workshops, don't hesitate to call me. So I'm watching here my question panel. If you have any questions, please use that one. It's unfortunately a screenshot from the old tool. The new tool, it looks a little bit different, but I think you found the question panel. And if you have a question later on, feel free to send us an email. And yes, I'm waiting maybe another minute to see if there are questions coming in so far. There's no questions. Nothing's coming in, so I think then we are finishing that webinar. Feel free to send us an email if you have any topics. For me, it was a pleasure to present Creo Simulation Elite. Later on, you'll get an email with a link of the recording. Later on, I will bring, let's say, the topics here also to my YouTube channel. I have to open it here, YouTube channel, this one. It's called Similar Simulation Tips for CAD Users. And here in that area on the playlists, you will see here tips and tricks, and in that area you'll see, let's say, the webinar about Creo Simulation Elite. It was a pleasure for me. Thanks for your time. See you soon. Have a great afternoon. Bye bye. Auf Wiedersehen.